Dear students, since today's class I forgot recording, therefore I am recording it again so that I can post it in Google Classroom. So today's topic was factors governing necessary condition for formation of ionic and covalent bond. Necessary condition for formation of ionic bond and covalent bond. So the first factor is ionization energy. This is also known as ionization enthalpy. So, lower the ionization energy of electropositive ion, greater the possibility of formation of ionic bond. Whereas in case of covalent bond is just opposite. Same ionization energy as we are talking about, IE. So high ionization energy favors formation of covalent bond. Second factor is electron gain enthalpy. Electron gain enthalpy of electronegative atom. So more value of electron gain enthalpy of electronegative atom, more possibility of formation of ionic bond. Formation of anion. Example, group 17. Here example is group 1, 2. Now same thing in covalent bond, electron gain enthalpy equal value of electron gain enthalpy. Third factor is electronegativity. Difference in electronegativity. Greater the difference, more ionic character. Here it is important to know a difference of 2 or more is necessary for formation of ionic bond. Take an example of formation of sodium chloride. Sodium has electronegativity value of 3. Chlorine has electronegativity value of 0.9. So the difference is 2.1. Therefore, it favors formation of ionic bond. Whereas in covalent bond formation, it should have equal electronegativities values. Equal electronegativity favors covalent bond formation. So these are first 3 factors which are important. Fourth factor in case of ionic bond is lattice energy. Now let us understand what is lattice energy. So the fourth factor is lattice energy. What is lattice energy? The energy released during formation of lattice is called as lattice energy. Now, greater the lattice energy, more possibility of ionic bond. Now, what is this lattice? Understand this first. During formation of ionic compound, cation and anion try to pack in definite geometry during formation of ionic compound. Cation and anion try to pack in definite geometry pattern forming three crystal. This is called as lattice. Now if we talk about this ionic compound sodium chloride, sodium and chloride come close to form Na plus and Cl minus. Now in practical scenario, each plus charge is surrounded by another minus charge, and that is how, and each minus charge is surrounded by plus charge, like this. Look at the picture. Again each minus will be surrounded as plus, each plus will be surrounded as minus, like this. Now during formation of lattice, energy is released. As a result, total energy of the system decreases. And therefore lattice have stable structure with definite geometry. Now there are two factors on which lattice energy is dependent upon. First factor is size of ion. Smaller the ion, more lattice energy. And second, charge on ion. More charge on ion, more lattice energy. So this was about ionic compound. Now in case of covalent compound, the factor which has important role is number of valence electrons. Valence electron 5, 6 and 7 favors covalent bond formation. Next important point is nuclear charge. Higher the nuclear charge, and small internuclear distance favors covalent bond formation. Next important point in a comparative study of ionic and covalent compound is relation between ionic bonding and covalent bonding and its position in the periodic table. So, next important factor is relation between ionic bonding and periodic table and relation between covalent bonding and periodic table. We already know, let me make a line. We already know that the tendency to form cation and anion depends upon their position in periodic table. And the number of electron lost or gain during formation of ionic bonding is known as electrovalency. This you already know. Now when we talk of electrovalency, there is another term which is important, which is called as variable Now, what is variable electrovalency? Having more than one type of electrovalency is called as variable electrovalency. Now, why variable electrovalency occurs? Look at this example. If we take example of lithium, where lithium loses one electron to form cation. Now, after formation of cation, it is also called as core or